In this lesson, we're going to talk about molecular geometry. That is, we're going to talk about shapes of molecules. The theory we use to predict what molecular shapes would be is known as Vespr, V-S-E-P-R, which is short for valence shell electron pair repulsion theory. Now, the main idea in Vespr is quite simple, actually. When you look at a particular atom, okay, you group the electrons that are sticking out of the atom into what are known as electron domains, okay, and think of these electron domains, these electron groups, to be oriented as far away from each other as possible, and the reason for that is, as we know, electrons repel each other. Okay, so it's important that you learn how to count the number of electron domains that are sticking out of an atom. Okay, a single bond will be counted as one group. A lone pair will be counted as one group, one electron domain. A double bond, even though it's two pairs of electrons, also counts as just one domain, one electron domain. And a triple bond, even though it's made up of three pairs of electrons, is also counted as just one electron domain. Okay, so the number of electron domains around the atom is called its steric number. So if you have a molecule, each atom in the molecule has what's called a steric number, the number of electron domains that are around, which is the number of electron groups that are sticking out of the atom. So let's look at this example right here for a molecule called urea. What's the steric number around each atom in the structure? So let's look at, we're not going to look at the terminal atoms, okay, because there's only one group sticking out of those. Let's just look at atoms that are not terminal atoms, that's connected to two other groups. Okay, so this nitrogen right here, let's look at that. Okay, it's got 1, 2, 3 single bonds and a lone pair. So the steric number for this nitrogen right here is 4. There are 4 groups of electrons, or 4 electron domains, that are sticking out of that atom. What about this carbon over here? I have 1, okay, I have 1, 2, and then this double bond counts as just one group. That's one electron domain. So this carbon atom has a steric number of 3. Okay, this nitrogen atom has 1, 2, 3, 4. So this nitrogen atom right here has a steric number of 4. Oxygen right here, we really don't worry about that one because that's a terminal atom. But if you want, you can say it's got a steric number of 3. It's got 1, a double bond counts as 1, the lone pair counts as 1, the other lone pair counts as another 1. So that's steric number of 3. Okay.